Problem. Which has the larger volume? A hemisphere of radius 5.14 centimetres or a cylinder with radius 3.3 centimetres and height 8.3 centimetres?
Well, that looked pretty hard, but we had a solution. We made them. These glasses have exactly those dimensions. The straight glass holds, wait for it, half a pint. Do you think that the round glass holds more or less than that? Well, there's an easy practical way to tell. But for the exam, we do need to calculate. And I'm not going to start on anything as difficult as that. So let's step back to an easier sort of volume to calculate. What is volume? It is a measure of how much space an object takes up. And man makes measures for his own convenience. He may measure in meters or in feet. For cubic measure, he works in cc's or cubic meters or cubic feet. But we could have started with a single unit like this. And from that unit, it is a small step to look at the easiest sort of volume which we can calculate. Now here we have 1, 2, 3, 4. 1, 2, 3. So we've got altogether 12 blocks, 4 times 3 on the top layer. And we have 1, 2, 3, 4, 5 layers. And that means that altogether here we've got 60 of these bricks. Another way of looking at it, slightly different and useful later on, is to say that the area of the top here is 4 times 3, that's 12, and then the height is 5, and that 5 12s are 60, of course the same answer. Now, it may look surprising that there are 60 of these bricks here, but they are so compactly put together that that makes the volume rather deceptive. What we've done is to multiply the area of the cross-section of the shape by the height. And that concept can be applied to any shape which is the same all the way down. Look at these. Can we apply that principle of area times height to find the volume of some of these? This first one is a cuboid. Now, the area of the end here might be something like 3.71 times 2.58. It doesn't matter if it's difficult. The principle is the same. This rectangle goes all the way down so that we can say area times height equals the volume. Now, we know with a rectangle that the area is L times W. So the full formula becomes V equals L times W times H. Now let us look at this one. In this case, the area of the end is a circle. But again, it's the same all the way down. So the formula is the same, V equals A times H. But this time, that area is the area of a circle, which we know to be pi r squared. So we're to the full formula of a cylinder, V equals pi r squared H. Even when you have a weird shaped end like this, which I've no idea how to calculate, the principle remains the same. If that stays the same all the way down, we will still have V equals A times H. But suppose the area does not stay the same all the way down, and there are a couple of shapes like that that we need to look at. This is the cone, and that is the sphere. Now, with the cone, we have a point here, and as you go down, the area of cross-section gets wider and wider until you get to the bottom. With the sphere, it starts as a point up here, widens out until you get to the equator, and then narrows down again until you're at the South Pole. So, what do we do with those? Well, we have thought of an idea. We're going to use a cylinder, and we've made this cylinder so that it will compare with these two. We've made that the same height as the cone and that the same height as the sphere. We have also arranged that the base of the cone exactly fits the cross-section area of the cylinder. And what is more, it fits the equator of the cone. So there we are. Let's start with this cone. What do you reckon about that cone? Do you reckon that is half the cylinder? Less than half? Well, let's check it in a very practical way. Over here we have a number of jars, all with exactly the same amount of liquid in it. And the amount of liquid is that which will fill the cone. There. Now, how many of those are going to go into here? Well, let's try. Well, that didn't make too much impression. Well, that's coming on quite a bit, because there's no guarantee that it's going to be equal number of these jugs anyway. But, well... And there we are. So that means that this is 3 times as much as that. Now, we know the volume of a cylinder is given by the formula V equals A times H. So the volume of the cone must be V equals 1/3 A times H. And as well, we know the area of the base. It's a circle again. So we have V equals 1/3 pi r squared h, and that formula will do for any cone. Now, for my next trick, I have something special to show you. There we go. Sound of rushing water. And this sphere has been made to fit exactly in there, like that. Now, how much room do you think there is round that sphere to fill up this? Well, let us try. Another of our conefuls of liquid. Glug, glug, glug. Stay down. And exactly so. So, the volume of the cylinder is equal to the volume of the sphere plus that jug full of liquid, which was the volume of the cone. So, we can do a calculation. The volume of the sphere plus the volume of the cone, that jug full, equals the volume of the cylinder. Now, the volume of the cylinder is A times H. The volume of the cone is 1/3 A times H. We just did that. So the volume of the sphere is the difference, 2/3 A times H. So here is the formula for the volume of the sphere. V equals 2/3 A times H. A is the cross-section area at the equator. So we replace it by pi r squared, giving V equals 2/3 pi r squared h. And for the sphere, its height is twice the radius, however big or small the sphere is. So we write now V equals 2/3 pi r squared times 2r, or finally V equals 4/3 pi r cubed, and that will work for any sphere. Now we have to work with the normal tools of the trade, pen and paper. We know the volume of a sphere. What about a hemisphere? Well, surely it's going to be half as much. So we have a formula, 2/3 pi r cubed. Now, for this one, we know the radius is 5.14. And that, at first, looks pretty horrific, working that out. But, remember, with our calculator, no hassle. So, 2 divided by 3 multiplied by 0.14, and that equals a bit over 284. 284. Now, let's go over and have a look at the cylinder. Now, for the cylinder, we have pi r squared h. We know the height is 8.3 centimetres and the radius 3.3. So let's work that out. Pi multiplied by 3.3 by 8.3, wait for it, equals, and that is marginally under 284. So the round glass is in fact marginally bigger than the straight glass. But, as near as, damn it, they're half a pint each. You know, I still don't quite believe this. Oh well.